I will tell you a story about how we work with systems analysis of water systems at DTU Environment. It takes its starting point in drinking water quality, but we actually work with all aspects of urban water systems. But in relation to drinking water quality, it is so that most guidelines around the world, they're building on the WHO guidelines for drinking water quality, which is based on a judgment of safety related to chemicals, pathogens, health, and the different technologies that we can use to provide the drinking water with. But it's a benchmark that sets a level for the adequate drinking water quality, and they actually recommend that it should be that you can improve upon that benchmark level of drinking water quality. And one example of how these guidelines are interpreted differently around the world is seen here, where we compare the guidelines in Denmark with the guidelines in Australia. And we see that actually just 17% of the Danish major drinking water utilities are complying with the Australian government recommended level of hardness. And also only a minor part of this major Danish utilities comply with the total dissolved solids content that is recommended in Australia. So there is room for improvement, and we have shown that this room for improvement is quite significant, actually. In this example here, we are looking at the hard Danish drinking water and see if we can soften it, removing the chalk from the water. And of course we can do that, adding energy into a process and chemicals into a process and removing the chalk. And the good thing is that we get a lot of benefits in the households. So we see that we can reduce the amount of soap needed, we can prolong the lifetime of appliances and reduce the energy consumption in the households. And this actually shows that even though we have an extra environmental burden from the increased treatment, we have an environmental benefit actually already with a very slight reduction in hardness levels in the drinking water. Another example of the importance of these drinking water quality issues is seen here, where we compare two different scenarios for water supply systems in Denmark. One that is based on groundwater, as it is today, simple groundwater treatment, hard groundwater provided as drinking water, compared to desalination, where we can make an optimized drinking water quality. In the current system as of today, we have a lot of fossil fuels in our energy mix, and that actually means that that moving from groundwater based to desalination, increasing the intensity of the treatment, we will increase the environmental impact from the system. But in the very near future, 2020, with a larger share of renewables in our energy systems, we may actually see a reduction. And that reduction in environmental impacts is mainly due to the fact that we can provide a better water quality of desalination. Of course, we could do the same by softening the already hard Danish groundwater. And this is, of course, not the only angle to this topic here, because we also have health impacts. And this graph here shows the number of cavities in the adults, dependent on the amount of calcium and fluoride in the drinking water. And going from a situation today around 2.5 to 3 cavities per person, and softening the water, we may increase it up to 3.5 to 4 or something in that range. Of course, with some uncertainty on the estimate, but it shows that there are health implications also by changing the water quality. And it's not only a Danish case. It's an important issue all over the world, for example, where we see a huge increase in desalination plants being installed every year. And all these desalination plants around the world, they provide water essentially free of minerals. And we could choose to blend it with some other type of drinking water. We could add minerals, and we could provide designed water quality that is beyond adequate, at least. And this is not often considered, but it should be, and we have the tools to do it. This was just one example of how we are using models of the physical water systems to tell us something about impacts on health and environment, but we use the same for impacts on economy and, for example, freshwater impacts. And we can gather these in multi-criteria assessments to say something about the performance of the future water systems. Going back to the example of drinking water quality, we have these benchmark values of recommended levels of different compounds in the drinking water. But we can actually go beyond adequate and provide some more specific aims for different compounds in the drinking water. And we have provided some for some compounds, but we intend in the future to expand this list. This is all about going beyond the adequate drinking water quality. Thank you.